Unit 2 intro notes. So we're going to review slope. Slope is what's known as the rate of change. It also describes the steepness of a line. So there are many different ways to find slope depending on the form or description that you're given for the information. So we're going to talk about all of these, but mainly slope is just the change in y over your change in your x values. And you can see this on the graph, change in y, how much you go up and down vertically, and change in x, how much you go left and right. So I always like to think of it as stairs. When you go up stairs, you have how much you have to lift your foot up and how much you have to move your foot over in order to get up the stairs. So stairs are built using slope, so is anything on a hill or anything that has a steepness. Additionally, we have that it's the steepness of a line. So the more vertical a line gets, the steeper it is. So we would call this one steep because it's closer to a vertical line. Here we have a gradual line, so that's closer to horizontal. So it's closer to looking like a horizontal line than it is a vertical line. So we call that more gradual or just less steep. But once it gets closer to looking like a vertical line, then we call that a steep line. So steep lines have a higher slope, so just a bigger number for slope, and gradual lines have a lower slope or a smaller number for slope. Additionally, with slope, we have different types of slope. So slope is always going to be a number. So sometimes that number will be positive, and it'll be positive if it's going up the mountain. So we always read slope or graphs from left to right. So if we look and we start at the left side of the graph and move to the right, we're going in the upward direction, which makes that positive. However, we can also have negative slope or downhill slope. So if we look from left to right, start at the left side, go to the right side, we're going in the downward direction. So that makes it negative. We also have two what we call special cases. They're just for certain lines. Horizontal line, so a straight left to right line has a slope of 0. You're not going up the mountain, you're not going down the mountain, you're just staying neutral, so that's a 0 slope. We also have a vertical slope, so when a line is vertical, the slope is undefined. We cannot calculate the value, and that makes it an undefined slope. You can also use Mr. Slope Guy to help you remember this. We have his positive eye, and his eyebrow represents that positive slope. Negative eye, the eyebrow represents the negative slope. There's the U here in the nose, so it reminds you that that vertical line is undefined. And then there's the 2 zeros around his straight line of a mouth, which reminds you that a horizontal line is 0 slope. So however you want to remember it, there's multiple different ways, but just a reminder that there are 4 different types of slope. But that slope is always a number. So for positive, it would be a positive number like positive 3. Or for negative, it could be negative 1/2. But there's always a number attached to it as well. All right, so we're going to practice finding the actual slope of linear functions given different representations. So the first representation we're going to be given is a table. So we're going to find the slope for this linear function using this table. So we're going to use change in y over change in x. So we have our y values listed on the right side of the table, our x values listed on the left, and we're going to find the change or the difference or how many numbers are separated between each value in our y values and in our x values. So to get from -3 to -2, how much do we have to go up or go down? Sometimes starting with those negative numbers, you can be like, oh, I don't know, because it's a different part of our brain that has to think about that. So sometimes I like to just go to the positive values. From 1 to 3, how much am I going up by? I'm going up by 2. From 3 to 5, I'm going up by 2. -3 to -1 is also up by 2. So every time we're changing by 2, we're going up 2. So that is what is known as our change in y. Our y values are increasing by 2 each time. Now we do the same thing with our x values. I'm going to take a look at our x values, and I can see if I look at my values, they're going up by 1 each time. From -2 to -1, I'm going up 1. -1 to 0, 1. 0 to 1. Each time we are increasing by 1. So my change in x is 1. So my slope here would be 2 over 1, which we can simplify to that whole number 2. Anything over the number 1 is just that number that's in the numerator. So we can also think of that fraction as division. If I do 2 divided by 1 to represent that fraction, we would get the value of 2. So that's how you find slope from a table. Next, we are going to calculate the slope from a graph. So in this case, we're still using change in y over change in x. However, with a graph, we usually just call it the rise over run. So with a graph, we are going to calculate our rise over run by drawing a little triangle between the 2 points. So here's point number 1, and here's point number 2. So we connect those 2 points with a vertical line and with a horizontal line. And then we calculate our rise over our run. So to calculate that, we just count the number of lines that we jump. So starting here and going down to that line, we have 2 jumps. And then starting here in the corner and going over to the other point, we have 4 jumps. So our rise is 2 and our run is 4. And we can reduce this fraction by dividing the top number and the bottom number by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So in this case, our slope is 1/2. And then we always need to check if that line is a positive slope, is it going up the mountain, or a negative slope, is it going down the mountain. So if I look at this line, from left to right, it is going down the mountain. It matches that negative picture. So I'm going to make this -1/2. And that is our slope for this graph. All right, 2 more representations and then we are done. We have calculate the slope from 2 points. So when we are given 2 coordinate points, we can calculate the slope using what is called the slope formula. So in order to calculate this, we're going to subtract our 2 y values, so change in y, and then subtract our 2 x values, change in x. So first off, we need to label our coordinate point. So a coordinate point always comes in an xy pair. And then since this is our first coordinate point, we call this x1, y1. And this is our second coordinate point, so we call this x2, y2. Now we're going to use this slope formula here to replace our variables with their values. So in this case, y2, I can go up to where I put my label y2, and that's the number 15. Minus the value of y1, so I go up to where I put my labels, y1, I labeled -10 as y1. So on the top we have 15 minus -10. Now we can do the same thing with our x values. We want x2. So I find my label of x2, which is -15, minus my value of x1, which I realize is 6. And now we just have to do the mathematical operations. So for this, I'm going to use the Desmos calculator. I have linked this calculator in Schoology, so you can find it in your calculator folder. So to start, I'm going to get this fraction. I'm going to click this fraction button right here so that I can type in the fraction. And then on the top, I need to put 15 minus negative 10. And then on the bottom, I'm going to put negative 15 minus 6. And we can see that our answer shows up over here. It's giving me my answer as a decimal. However, if I click this little fraction button, it'll convert it to a fraction for me. And I can see that my slope is negative 25 over 21. And that's how you find the slope from 2 points. And then the last one, find a slope from the equation. When an equation is written in what we call slope-intercept form, which we're going to talk more about in our next lesson, the slope is always the number that is right in front of that x value. So we have y equals 8x minus 9. That 8, which we call the coefficient of x, that 8 is our slope. It'll always be the number that's touching x when it's written in this form right here. All right, that is all your notes. I apologize for the longer video since we had so many forms of slope to go through, but you can go ahead and move into your very short practice.